Hello everyone, and welcome to my portfolio video. In this series, I will showcase how I approach structural design and analysis projects. Today, I will walk through the design and analysis process of elevator tower. For elevator tower, this tower for Rockwool factory, which is real project I worked in the Czech Republic. As you see, this is the elevator tower. I can turn that side. As you can see, in maybe somebody know, in glass factory, in Rockwool factory, there is some furnace building, and this is the elevator building. There is some material inside of the elevator is carried by conveyor and elevator to throw to the furnace building. I can explain these steps maybe soon, but for now we will consider to the elevator tower. This is the basic design. In some cases, basic design may be provided by the client. Maybe they can give to you, for example, furnace building is ready, and they can give the furnace building, and you can make the basic design according to this. For example, in this project, client gave one building is 20 meters high, and according to this, our designers made the buildings. Designers made the building like this. It depends on your idea. Basic design may be provided by client, or we may develop it ourselves based on site condition and requirements. Either way, it forms the foundation of the project. Okay. Firstly, this is the basic design. I will transfer the elevation and K dimensions from the basic design. I can turn here like this, for example. I will take this, for example, show panels, large panels, sketch tools, measurement. For example, from here to here, I will measure here, and I will transfer sub SIP 2000 to create initial model. For this project, I will incorporate loads such as wind, seismic activity, temperature variation, and dead loads. This step will allow me to visualize the primary structural element like a column, beam, and braces. So I will take the elevation data from here, X and Y data. I will transfer to the SAP 2000, or what I am doing, I can transfer to the Rhino. I use Rhino for the creating the basic design. Is a very useful program for the basic design, because you can draw. It's a very flexible program. Every time, wherever you want to go with the line, you can go anywhere. Okay, like this. like this. You see, like this, like this. Just you can write the number and you can go. Why I am creating the model in the Rhino is very flexible. It is giving exact dimension solution. Exact dimension is giving the exact dimension. That is why I am using. If you want, you should not use this. You can just directly transfer the SAP 2000 and then you can create your SAP 2000 model. After you transfer your datas, your elevations, your X and Y coordinate systems, and you will see this initial modeling gives you a clear picture of the steel elements that will form the elevator tower structure. After you create this, and it will give you you will imagine your design, okay? And the elevator towers have some as you see, some equipments, like there is a bunker here, and there is a vibro feeder here. These all elements are the basic design. As you see, there is nothing here and there is nothing here, and screw feeder and vibrating feeder, screw feeder. We will create these bunkers and vibro feeders according to some calculations. We will calculate capacity of this bunker and capacity of this vibro feeder and the motor connections, motor capacities. We will calculate and we will do like this. These components also will contribute to leave loads on the structure. I will model these components in Autodesk Inventor or SolidWorks and or SpaceClaim. As you know, if you know Autodesk Inventor, you can use SolidWorks or SpaceClaim, or such as these programs. I don't know, it depends on your ability. And we will also determine statistical analysis of these materials. For example, we will use 2mm plate for this bunker, and we should understand the 2mm plate is okay or not for this. For this, we will calculate the loads also, loads inside of the bunker, and then we will calculate statistical analysis of this bunker. And based on this calculation, I will update SAP 2000 model also. How, you know, for example, we calculated this. We will apply wind load, earthquake load, or temperature load, some leave load, and additionally we will add this leave and dead load from the equipment. As you know, there is some load here and here, you know. We will add these loads also. This ensures that structural model accurately reflects the real world conditions. We will see the real world condition, you know. We will see all of these laws. With all laws defined, I will finalize SIP 2000 model and perform a complete structural analysis. This analysis verifies that the structure can safely handle all laws under various conditions. You know, the analysis also helps me optimize the design by ensuring the structural elements are neither over nor under designed. You know, for example, I am talking about the equipment design. In equipment design, we can see some L profile here and here. Maybe initial design is wrong. Maybe we will use different profile for here or for here. I don't know. It depends on the calculations, you know. Finally, after I make all the calculations and all the designs, I am not just talking about the calculations. After calculations, we will make the design according to these calculations. If you want me to give a example, for example, I will use 3 millimeter. Initially, I will use 3 millimeter plate for the case of elevator, and I will calculate 3 meter is enough or not, or if it is not enough, if it is not sufficient, I will change to the 5, to the 6. I will test, and then at the end of the day I will optimize to this thickness. So finally we will see the most economical and most safe materials in our site. Okay, and that is how I will approach the design and structural analysis and integrated equipment. Thank you for watching. If you find this interesting, don't forget like and subscribe to follow more of my design process. See you in next video. In next video we will start with our structural design of building structure. We will start from the building structure. Thank you.